Welcome to First Year Microeconomics. So far, when we've considered gains from trade, we've used a table to show Becky and Tom's output. Today we're going to introduce a simple diagram that also captures the benefits from gains from trade. It's called the Production Possibilities Frontier. Formally, the Production Possibilities Frontier shows for a given level of inputs how much potential output is possible for a person, a business, a group, a country, or indeed the whole world. The Production Possibilities Frontier is a very simple diagram, but it is amazingly useful. It's used in a whole range of applications. For example, management consultants often use a Production Possibilities Frontier to work out if a particular business is operating efficiently or not. They tend to call it the Efficiencies Frontier for the firm. In our application today, we're going to first look at the Production Possibilities Frontier for Tom, then the Production Possibilities Frontier for Becky, then we're going to consider Tom and Becky as a group and look at the Production Possibilities Frontier for that group, for Tom and Becky together. Now, to draw a Production Possibilities Frontier, we first have to say what is the level of inputs. So we'll give Tom and Becky 48 hours each of time in which to work. Now, just a reminder, remember that it takes Tom 4 hours of work to produce a kilogram of potatoes, and it takes Tom 8 hours of work to produce a kilogram of tomatoes. In contrast, it takes Becky 2 hours per kilogram of potatoes and 6 hours per kilogram of tomatoes. You might want to write those numbers down because we're going to keep referring back to them. The first step in drawing a Production Possibilities Frontier is to draw our axes. Our axes allow us to look at two, but only two goods at a time. So, on the vertical axis, we're going to have the quantity of potatoes. On the horizontal axis, we're going to have the quantity of tomatoes. And we're going to draw a diagram that answers a very simple question. What combinations of potatoes and tomatoes can Tom produce in 48 hours? Now remember that it takes Tom 4 hours to produce 1 kilogram of potatoes. So if he spends all his time, his entire 48 hours, producing potatoes, then he can produce 12 kilograms of potatoes, but no tomatoes. So we're here on the vertical axis. Now, what happens if Tom wants to produce 1 kilogram of tomatoes? Well, remember, it takes Tom 8 hours to produce 1 kilogram of tomatoes. So in order to get the 8 hours to produce that kilogram of tomatoes, he has to give up some potatoes. In the 8 hours, he could have produced 2 kilograms of potatoes. So Tom has to reduce his production of potatoes by exactly 2 kilograms in order to get the 1 kilogram of tomatoes. And that, of course, is just Tom's opportunity cost of a kilogram of tomatoes. 2 kilograms of potatoes foregone. So it's possible for Tom, in his 48 hours, to produce 10 kilograms of potatoes and 1 kilogram of tomatoes. How do we show that in our diagram? But that is just our point up here, where you have 10 kilograms of potatoes and you've got the 1 kilogram of tomatoes. So this point, or this bundle of goods, is another point on Tom's Production Possibilities Frontier. He can produce that bundle in his 48 hours. Well, what else could Tom produce? Well, Tom might want to produce 2 kilograms of tomatoes. But if he produces 2 kilograms of tomatoes, that takes him 16 hours. And that means that he has 48 minus 16 hours worth of time left to produce potatoes. So he's got 32 hours. In his 32 hours for potatoes, he can produce, well, 32 divided by 4, that's 8 kilograms of potatoes. How do we show that bundle on our diagram? Well, it's just this point up here, where we have 8 kilograms of potatoes and we've got 2 kilograms of tomatoes. So this point, or this bundle here, is just another point on Tom's Production Possibilities Frontier. Now we could continue. Let's jump ahead a bit. Let's suppose that Tom just wants to produce tomatoes and doesn't produce any potatoes. Well, how do we show that point on our diagram? Well, remember that in his 48 hours, Tom can produce 48 divided by 8, that's 6 kilograms of tomatoes at most. Of course, that means he doesn't produce any potatoes. So we can show that in our diagram. It's just this point down here. Notice that at that point we have 6 kilograms of tomatoes, but we have 0 kilograms of potatoes. So this bundle is just another point on Tom's production possibilities frontier. And we can keep going. Tom could, for example, produce half a kilogram of tomatoes, and if he did that, he could produce 11 kilograms of potatoes. Or he might decide to produce 5 kilograms of tomatoes, in which case he could produce 2 kilograms of potatoes. And we can keep going, working out what Tom can produce in his 48 hours. And if we did that, we'd end up with a whole range of points. And if we joined up those points, then they would form a straight line, like the red line here, which is just Tom's production possibilities frontier. It shows all the combinations of potatoes and tomatoes that Tom could produce in his 48 hours. Of course, it shows alternative options for Tom. Tom could produce 8 kilograms of potatoes and 2 kilograms of tomatoes, or he could produce 10 kilograms of potatoes and 1 kilogram of tomatoes, or he could produce 6 kilograms of tomatoes and no potatoes. So every point on this red production possibilities frontier represents an alternative choice that Tom can make when he works for 48 hours. What about the points inside the production possibilities frontier? Like a point, say down here. That point represents the situation where Tom is not being technically efficient. Notice that that point is inside or underneath the production possibilities frontier. That means that Tom is not producing the maximum level of output that he could given his level of inputs. For example, starting at that point, Tom could have more tomatoes, or he could have more potatoes, or he could have a bit more of both. The production possibilities frontier represents Tom's technically efficient alternative options when he works for 48 hours. Notice that the slope of Tom's production possibilities frontier is just -2. That just represents that he has to give up 2 potatoes every time he wants 1 more tomato. And that's of course just Tom's opportunity cost of tomatoes in terms of potatoes foregone. And notice that because Tom's opportunity cost is constant, doesn't matter how many potatoes he's producing, he always has to give up 2 potatoes to get 1 more kilogram of tomatoes. Because that's constant, we have a straight line for Tom's production possibilities frontier. This constant marginal opportunity cost is also called a constant marginal rate of transformation for Tom. The rate at which he can transform potatoes into tomatoes or tomatoes into potatoes by changing how he uses his time remains constant. So we say that Tom's technology involves a constant marginal rate of transformation. Now, what about Becky? Remember that Becky also has 48 hours in which to work, and she takes 2 hours to produce 1 kilogram of potatoes, so if she just concentrated on producing potatoes without producing any tomatoes, she could produce up here at 24 kilograms of potatoes and no tomatoes. She takes 6 hours to produce a kilogram of tomatoes, so if she just concentrates on producing tomatoes, she can produce 8 kilograms, so she would be down here, 8 kilograms of tomatoes and 0 potatoes. And of course in Becky's situation, her marginal opportunity cost is constant. Every time she wants to produce another kilogram of tomatoes, she has to give up 3 kilograms of potatoes. So her marginal rate of transformation is constant, and it's 3. And so we have a straight line production possibilities frontier for Becky as well. We have a slope of the production possibilities curve is equal to 3 or -3. So Becky's production possibilities frontier is this straight red line, and the slope of that line is just simply Becky's opportunity cost of tomatoes in terms of potatoes foregone. Note that while Becky's production possibilities frontier looks a lot like Tom's, it's actually steeper than Tom's. Remember, Becky's opportunity cost of tomatoes is 3 kilograms of potatoes foregone. That's more than Tom's opportunity cost of tomatoes, which was 2 kilograms of potatoes foregone. So Becky's technology also has a constant marginal rate of transformation, but it's a different rate to Tom's. So we've seen the production possibilities frontier for Tom by himself and Becky by herself. What about if we have Tom and Becky together? What does their joint production possibilities frontier look like? Well, let's start off by thinking about how many potatoes Tom and Becky could produce if they just produced potatoes. How many? Well, remember that Becky has 48 hours, and in her 48 hours she can produce 24 kilograms of potatoes. In Tom's 48 hours, he can produce 12 kilograms of potatoes. So together they can just produce 36 kilograms of potatoes. So the first point on their production possibilities frontier is this point up here. 36 potatoes, 0 tomatoes. Now, what about if Tom and Becky decide they want to produce some tomatoes? Let's say they want to produce 1 kilogram of tomatoes. They now have a choice. Who will produce the tomatoes? They could get Tom to produce the 1 kilogram of tomatoes. That would mean that Tom has 8 hours less to produce potatoes. Or they could have Becky produce the 1 kilogram of tomatoes. That would mean she would have 6 hours less to produce potatoes. And so initially you might say, well, if Becky produces a kilogram of tomatoes, she takes less time, so maybe she should do it. But wrong. That is thinking in terms of absolute advantage, not comparative advantage. Remember, the opportunity cost of having Tom produce that first kilogram of tomatoes is 2 kilograms of potatoes foregone, whereas the opportunity cost of having Becky produce the 1 kilogram of tomatoes is 3 kilograms of potatoes foregone. So if Tom and Becky decide that Becky should produce that first kilogram of tomatoes, sure, she'll only take 6 hours, but Tom and Becky together will be 1 kilogram of potatoes worse off. What they want to do is have the person with the lower opportunity cost of tomatoes start producing the tomatoes first, and that's Tom. So they're going to have Tom produce the 1 kilogram of tomatoes. That will mean they have to give up 2 kilograms of potatoes. Then if they want another kilogram of tomatoes, they still want Tom to do it. He's got the lower opportunity cost. So they can end up with 2 kilograms of tomatoes and 32 kilograms of potatoes, and so on. Indeed, Tom and Becky want Tom to be producing more and more tomatoes and giving up 2 kilos of potatoes whenever he produces an extra kilogram of tomatoes, until we get to this point here, 24 kilograms of potatoes and 6 kilograms of tomatoes. At that point, Tom has now specialised in producing tomatoes, and Becky is producing all the potatoes. So we just have the first bit of Tom and Becky's joint production possibilities frontier. And of course that first bit just looks like Tom's production possibilities frontier. It has a slope of -2, representing Tom's opportunity cost of tomatoes in terms of potatoes foregone. As Tom and Becky move along this production possibilities frontier, Tom is producing more and more tomatoes, fewer and fewer potatoes, but Becky is always producing just potatoes. Now, what happens if Tom and Becky want more than 6 kilograms of tomatoes? What happens if they want a 7th kilogram? Who should they get to produce that extra kilogram of tomatoes? Well, they can't get Tom to produce any more tomatoes. Tom is spending his entire 48 hours producing the 6 kilograms of tomatoes they have at the moment. So the only way they can get another kilogram of tomatoes is if Becky produces it. So to produce the 7th kilogram of tomatoes, Becky has to spend 6 hours producing that kilogram of tomatoes. And of course that means that Tom and Becky together have to give up 3 kilograms of potatoes. And that's represented by the movement along this second bit of Tom and Becky's production possibilities frontier. As we move from 6 kilograms of tomatoes and 24 kilograms of potatoes, as we move towards more and more tomatoes, Becky is spending more of her time producing tomatoes and less of her time producing potatoes. Of course, Tom is just producing tomatoes on that part of the production possibilities frontier. Notice that the slope of the production possibilities frontier in this region is given by 3, or minus 3. They have to give up 3 kilograms of potatoes for every kilogram of tomatoes, and of course that's just Becky's opportunity cost. And that can continue until they reach the point down here where they have 14 kilograms of tomatoes. They reach that point when both Tom and Becky are spending all their time producing tomatoes and no potatoes. So Tom and Becky's joint production possibilities frontier is actually just made up of the first bit, which was Tom's production possibility frontier, and the second bit, which is Becky's production possibility frontier. Starting from the situation where Tom and Becky just have potatoes, if they want to produce some tomatoes, they first get Tom to produce the tomatoes, because he has a comparative advantage in tomatoes, and that continues until Tom's spending all his time producing tomatoes. This point here where Tom is specialised in tomato production, Becky is specialised in potato production. Then if Tom and Becky want more tomatoes, Becky has to spend some time producing tomatoes, and that continues until both Tom and Becky are just producing tomatoes. Notice that we have a kink in the production possibilities frontier, where the slope changes from minus 2 to minus 3, just representing the movement from Tom's opportunity cost to Becky's opportunity cost. Because the number of potatoes that Tom and Becky have to give up to get an extra kilogram of tomatoes increases as they produce more and more tomatoes, we call that a diminishing marginal rate of transformation. And it's represented by this outwardly kinked, or what's sometimes called bowed outwards, production possibilities frontier. So Tom and Becky's joint PPF is bowed out. We can use our joint production possibilities frontier to show the gains from trade for Tom and Becky. Remember that if Tom and Becky didn't trade, and they each spent half of their time producing potatoes and tomatoes, we would be at this point here, where together they have 18 kilograms of potatoes, they have 7 kilograms of tomatoes. And notice that point is inside the joint production possibilities frontier. In other words, that point is technically inefficient. Or another way of putting it is, by specialising in trading, Tom and Becky can have more potatoes and more tomatoes. They can have more of everything, compared to autarky, or if they just try and produce the products that they want for themselves. While we've seen Tom and Becky's joint production possibilities frontier, we could do the same for an entire country. If we had an entire country producing potatoes and tomatoes, then the production possibilities frontier for that country would probably look something like this. The logic of the shape of the joint production possibilities frontier for the country follows the same logic as for Tom and Becky. If the country is producing lots of potatoes and very few tomatoes, and it wants to produce some more tomatoes, then it would want the people with the lowest opportunity cost of tomato production to initially produce those extra tomatoes. Now, as the country produces more and more tomatoes, the people who have the lowest opportunity cost of tomatoes become specialised in tomato production, and the country has to move people who have a higher and higher opportunity cost into tomato production. And eventually, as you get lots and lots of tomatoes and very few potatoes, the opportunity cost for the country becomes very high. People who are really great potato farmers and terrible tomato farmers, well, the only way the country can get more tomatoes is by having those people produce more tomatoes and producing fewer potatoes. And this is reflected in the shape of the countrywide production possibilities frontier. When there's very few tomatoes, the production possibilities frontier is relatively flat, reflecting that the opportunity cost of producing tomatoes is relatively low. As more and more tomatoes are produced, the curve becomes steeper and steeper, reflecting that the opportunity cost of another kilo of tomatoes in terms of potatoes foregone gets higher and higher. So the countrywide production possibilities frontier is bowed out, or we sometimes say concave to the origin, and that again just reflects diminishing marginal rate of transformation or increasing opportunity cost of tomatoes for the country as a whole. Now, of course, most countries produce things other than just potatoes and tomatoes. So our countrywide production possibilities frontier that we've drawn here is obviously abstract. It's a big simplification on the real world. What we've actually got here is our first economic model. And in the next presentation, we're going to find out a lot more about what economic models are. But to summarise this presentation, you've now seen how to construct a production possibilities frontier. It shows the maximum amount of goods and services that an individual or a group or a country can produce with a given amount of inputs. If a country, a person, or the group is operating on the boundary of a production possibilities frontier, then their production is technically efficient. If they're operating inside the boundary, then they're technically inefficient. By reorganising production, they could end up with more of everything. And that's exactly what trade can do. It can move us from technically inefficient production to technically efficient production, where we can have more of everything for everybody. How do we do that? Well, we specialise according to comparative advantage.